Section 2. The Atmosphere. Earth is surrounded by a mixture of gases known as the atmosphere. Nitrogen, oxygen, carbon dioxide, and other gases are all parts of this mixture. Earth's atmosphere changes constantly as these gases are added and removed. For example, animals remove oxygen when they breathe in and add carbon dioxide when they breathe out. Plants take in carbon dioxide and add oxygen to the atmosphere when they produce food. Gases can be added to and removed from the atmosphere in ways other than through living organisms. A volcanic eruption adds gases. A vehicle both adds and removes gases. The atmosphere also insulates Earth's surface. This insulation slows the rate at which the Earth's surface loses heat. The atmosphere keeps Earth at temperatures at which living things can survive. Composition of the atmosphere. Figure 10 shows the percentages of gases that make up Earth's atmosphere. Nitrogen makes up 78% of the Earth's atmosphere. It enters the atmosphere when volcanoes erupt and when dead plants and animals decay. Oxygen, the second most abundant gas in Earth's atmosphere, is primarily produced by plants. Gases including argon, carbon dioxide, methane, and water vapor make up the rest of the atmosphere. In addition to gases, the atmosphere contains many types of tiny, solid particles or atmospheric dust. Atmospheric dust is mainly soil, but includes salt, ash from fires, volcanic ash, particulate matter from combustion, skin, hair, bits of clothing, pollen, bacteria and viruses, and tiny liquid droplets called aerosols. Air pressure. Earth's atmosphere is pulled toward Earth's surface by gravity. As a result of the pull of gravity, the atmosphere is denser near Earth's surface. Almost the entire mass of Earth's atmospheric gases is located within 30 kilometers of our planet's surface. Fewer gas molecules are found at altitudes above 30 kilometers. Therefore, less pressure at these altitudes pushes downward on atmospheric gases. The air also becomes less dense as elevation increases, so breathing at higher elevations is more difficult. Layers of the atmosphere. The atmosphere is divided into 4 layers based on temperature changes that occur at different distances above the Earth's surface. Figure 12 shows the 4 layers of Earth's atmosphere. The troposphere. The atmospheric layer nearest Earth's surface is the troposphere. The troposphere extends to 18 kilometers above Earth's surface. Almost all of the weather occurs in this layer, as shown in Figure 13. The troposphere is Earth's densest atmospheric layer. Temperature decreases as altitude increases in the troposphere. The stratosphere. Above the troposphere is the stratosphere. The stratosphere extends from 18 kilometers to an altitude of about 50 kilometers. Temperatures rise as altitude increases in the stratosphere. This change happens because ozone in the stratosphere absorbs the sun's ultraviolet, UV, energy and warms the air. Ozone, O, is a molecule that is made up of 3 oxygen atoms. Almost all the ozone in the atmosphere is concentrated in the ozone layer in the stratosphere. Because ozone absorbs UV radiation, it reduces the amount of UV radiation that reaches the Earth. UV radiation that reaches Earth can damage living cells. The Mesosphere. The layer above the stratosphere is the Mesosphere. This layer extends to an altitude of about 80 kilometers. The Mesosphere is the coldest layer of the atmosphere, and its temperatures have been measured as low as -93 degrees Celsius. The Thermosphere. The atmospheric layer located farthest from the Earth's surface is the thermosphere. In the thermosphere, nitrogen and oxygen absorb solar radiation, which results in temperatures that have been measured above 2,000 degrees Celsius. Even though air temperatures in this layer are very high, the thermosphere would not feel hot to us. Air particles that strike one another transfer heat. The air in the thermosphere is so thin that air particles rarely collide, so little heat is transferred. Nitrogen and oxygen atoms in the lower region of the thermosphere, about 80 kilometers to 550 kilometers above Earth's surface, absorb harmful solar radiation, such as X-rays and gamma rays. This absorption causes atoms to become electrically charged. Electrically charged atoms are called ions. The lower thermosphere is called the ionosphere. Sometimes ions radiate energy as light. These lights often glow in spectacular colors in the night skies near the Earth's north and south poles, as shown in Figure 14. Energy in the atmosphere. As shown in Figure 15, energy from the sun is transferred in Earth's atmosphere by three mechanisms: radiation, convection, and conduction. Radiation is the transfer of energy across space and in the atmosphere. When you stand before a fire or a bed of coals, the heat you feel has reached you by radiation. Conduction is the flow of heat from a warmer object to a colder object when the objects are placed in direct physical contact. Convection is the transfer of heat by air currents. Hot air rises and cold air sinks. Thus, if you hold your hand above a hot iron, you will feel the heat because a current of hot air rises up to your hand. Heating of the atmosphere. Solar energy reaches the Earth as electromagnetic radiation, which includes visible light, infrared radiation, and ultraviolet light. The sun releases a vast amount of radiation, but our planet only receives about 2/billionths of this energy. This seemingly small amount of radiation contains a tremendous amount of energy, however. As shown in Figure 15, about half of the solar energy that enters the atmosphere passes through the atmosphere and reaches Earth's surface. The rest of the energy is absorbed or reflected in the atmosphere by clouds, gases, and dust, or it is reflected by the Earth's surface. On a sunny day, rocks may become too hot to touch. If the Earth's surface continually absorbed energy, the Earth would get hotter and hotter. The Earth does not continue to get warmer because the oceans and the land radiate the energy they have absorbed back into the atmosphere. You may have noticed that dark-colored objects become much hotter in the sun than light-colored objects. Dark-colored objects absorb more solar radiation than light-colored objects, so dark-colored objects have more energy to release as heat. This is one reason the temperature in cities is higher than the temperature in the surrounding countryside. The movement of energy in the atmosphere. Air that is constantly moving upward, downward, or sideways causes Earth's weather. In the troposphere, currents of less dense air warmed by the Earth's surface rise into the atmosphere, and currents of denser cold air sink toward the ground. As a current of air rises into the atmosphere, it begins to cool. Eventually, the air current becomes more dense than the air around it and sinks instead of continuing to rise. So the air current moves back toward Earth's surface until it is heated by the Earth and becomes less dense. Then the air current begins to rise again. The continual process of warm air rising and cool air sinking moves air in a circular motion, called a convection current. A convection current is shown in Figure 15. The greenhouse effect. The gases in Earth's atmosphere act like the glass in the car shown in Figure 16. Sunlight that penetrates Earth's atmosphere heats the surface of the Earth. The Earth's surface radiates heat back to the atmosphere, where some of the heat escapes into space. The remainder of the heat is absorbed by greenhouse gases, which warms the air. Heat is then radiated back toward the surface of the Earth. This process in which gases trap heat near the Earth is known as the greenhouse effect. Without the greenhouse effect, the Earth would be too cold for life to exist. The gases in our atmosphere that trap and radiate heat are called greenhouse gases. None of the greenhouse gases have a high concentration in Earth's atmosphere. The most abundant greenhouse gases are water vapor, carbon dioxide, methane, and nitrous oxide. The quantities of carbon dioxide and methane in the atmosphere vary considerably as a result of natural and industrial processes, and the amount of water varies because of natural processes.